Hello, everyone, and welcome to the panel on Wrangling Big Data Sets in the Real World. We're going to cover a lot of ground. You already know me. I'm Daniel Jeffries, the Managing Director of the AI Infrastructure Alliance, and I'm here with three wonderful guests who are going to do a quick intro so you all get to know them as well as I do. Hyun, why don't you start us off?
All right. Hi, everyone. My name is Hyun, co-founder and CEO of Superb AI. Superb AI's mission is to lower the interest barrier to machine learning. We help companies label, manage, and curate computer vision data sets easily using automation technology, and we help them get to production level AI faster.
Awesome. Thanks so much. And Joe, why don't you go next?
Hi, everyone. I'm Joe Doliner, founder and CEO of Packaderm. Packaderm is a data versioning and lineage tracking system that does distributed processing.
Fantastic. Thank you, good sir. And HO, follow us up here. Take it home. And
so HO Maycott, CEO of FeatureBase. We're a real-time database built entirely on bitmaps. And we believe that everything in the future should be computed in real time and not be pre-processed or pre-aggregated.
That is a bold statement. So maybe we'll explore a little bit of that as we go along. But let's start off with an easier one. What is different about dealing with data in an AI/ML system versus kind of traditional coding apps? And might be a good bet to, we could probably start off with any of us in this, but let's go around the horn. Why don't we start with JD on this one, since this is near and dear to Packaderm's heart?
Yeah, absolutely. So, when you're dealing with data in an application that you're programming, it really plays an entirely different role than an AI/ML system. In that you'll normally have that data in a database, or you'll have it accessible in files, and those will be things that you'll read in during runtime. And the data is there for the entire duration of the application. In an AI/ML system, that happens in sort of two distinct steps, wherein data gets fed into a model training process, and then it's not like that model has access to that data while it's serving. It gets computed into this gigantic bag of weights, essentially, and that in a sense contains the fingerprints of the data in it, but it doesn't actually have access to the data. So that's at a high level what's different about how the data is flowing through the system. What that means in terms of how you want to be able to handle the data is that in one case, you kind of want a database where you can do lookups, and in another case, you want a system that's going to allow the data to flow through and allow you to track that data as it flows through. And so I don't want to get ahead of us because I have seen sort of what the questions are, but things that matter in that type of stuff is like how real time the data can be, how you can track the lineage and version that data as it goes in, and how you can sort of link it to the model that came out so that you can do things like quality control on the model. You can understand anomalies in your data that lead to anomalies in your model, things like that. I sense I've given a few things here that HO and Hyun might want to chime in on as well. So I'll pass it over to them.
Yeah, and
I'll chime in a little bit.
Yeah, please. That's what I was going to say. Go for it next, because I think there's the perspective of dealing with it from kind of the labeling standpoint, which is just a radically different step that really doesn't exist in traditional coding. Give us some insight there.
So I was gonna say, I think one of the key differences has to do with at which phase of development do you start dealing with data. So like in typical software engineering, the data is oftentimes a byproduct of the deployed software, like rather than something that's part of the development process itself. So in such cases, dealing with data comes after you deploy the software, whether it's, like your users using your product or the database is getting populated and so on and so forth. In comparison, when you are developing AI ML systems, you have to deal with the data from the get-go, right? You have the training data, and I think, dealing with data in ML systems is similar to dealing with software code base in traditional software engineering in a couple of ways. For example, you want to keep track of like data versions and change logs, just like you do for software code. Also, you want to for example, test ML systems using data, just like how you write test cases for software. So this is a concept that I like to call data-driven or data-centric unit testing. So that you could write test cases for, say, an incoming new batch of training data that checks for the data distribution or data drift, or you could write test cases for testing the accuracy of your trained ML models. Like if you're working on autonomous driving use case, you can use like a set of, say, like rainy day images to test whether your new version of model works well for that case, and just go through that list of like test cases or test sets. So,
are you seeing that as common already, by the way? Because right before we get to HO, because it was funny because I was writing about sort of unit tests and being applied to AML 3 or 4 years ago, and people thought it was nuts. And it seemed so obvious to me that we would get there. I mean, are you actually seeing it in generally in production now as like much more common, or is it still aspirational?
It's definitely getting more common, but I definitely see, I think it's much rare for computer vision use cases. And it's more common for like structured data machine learning.
Yeah. Unit testing on code is oftentimes aspirational too, though. So,
oh yeah.
So like we can't,
HO, so I cut you off there. So jump on in about kind of where you stand on everything here.
Yeah, I think those were some really good points that the others made. I think practically speaking, data is just much more scrutinized in machine learning than it is in a typical application. So it has to be a lot more accurate, a lot more cleaned up. So I think that's a piece of the puzzle that's different. I think historical data plays a much bigger role in machine learning than it does in maybe a traditional application. And I think the 2 stages of data are interesting, right? Stateful and exploratory work during training, and stateless, lookups during production. And I think, one of the big things there that ends up happening is that the data needs to be as efficient as possible when you take it to production, or your costs can go through the roof. We're starting to see a lot of that, right? And we're starting to see a lot of move out of the clouds because people are afraid of these costs. And so, ultimately, we're going to need a much more efficient approach to data and compute to solve the problems in production for us. So those are some of the differences that I see out there.
And that's interesting that you're seeing. Are you actually seeing people pulling it out of the cloud? I mean, it still seems like the cloud has an order of magnitude sort of cheaper versus like building your own when you're talking about a giant scale. But if you're seeing that, that's pretty interesting.
Yeah, I'm in this amazing Discord channel, which you should all join. It's called Yet Another Infrastructure Group. And a lot of the discussion there, like some of the famous infrastructure investors like Martin Casado, they love calling out every time somebody tweets about their on-prem mega clusters that they're building to go do the training, in-house. And so it just seems to at least be a very relevant talking point at the moment. So whether it's actually happening or not, there's a lot of discussion around it for sure.
There certainly seems to be a lot of just like interest in that type of stuff. Like if you just look at the buzz that Stable Diffusion has got compared to like some of the other just like hosted solutions, like everybody got really, really excited as soon as they could run this on their own machine. Not that they weren't excited before.
True, although their cluster of V100s is running in AWS. So I'm going to
yeah, that doesn't necessarily mean, but like, I mean, I've been running it on my desktop, and just like the fact that I can, because I have a pretty nice graphics card on there, and it's like pretty sweet to be able to do that.
That has been pretty cool. We could probably get to the whole concept of open AI as well, but we might rattle on that for an hour because it's pretty exciting. But let's go to a slightly less exciting question, but also really relevant, right? So one of the things we found out in the survey that we did for the big IA report that I talk about here as well during this conference is that the top concern was kind of wrangling that data and then sort of getting it labeled, dealing with it, processing it, QAing it, doing all these things. That was really like where people were spending the most resources and time. And we also found that people were hiring data engineers at like a 2-to-1 ratio, right, to data scientists, right? And we've certainly seen, labeling companies and such, get some big wins in recent days too, which tells me that people are moving into potentially more interesting machine learning based use cases past these kind of, we can all do, churn prediction, et cetera. Why do you think so many of the tools on the market are kind of still focused on the models and so few up until this point have been focused on kind of the data engineers and the data wranglers. And maybe we'll start with Jan on this.
Yeah. Actually, when I read this question, I was going to say that I kind of disagree. I do see a lot of new toolings that's just coming up, focused on data. And the biggest reason why, people have been focused on model-centric tools so far is just because, the fact that data-centric AI hasn't been around for so long. But I do see like a strong trend in companies moving towards data-centric AI and thus needing tools for tools focused on data. And it's interesting because I see this trend regardless of how much data a company has. So, like for example, like large enterprises that have previously relied on like open source, off-the-shelf machine learning models have started customizing these models to fit their needs. And for many applications of AI, you don't really need a new novel deep learning architecture, right? An open source model can be enough. So for these companies, that already have tons and tons of data, they're just throwing data to these open source models to retrain them. And then that makes naturally they now look for toolings that's focused on data that can help them manage and analyze large scale data sets, right? And the case is also the same for also true for companies that have very scarce data. So these companies basically need to maximize the juice out of the limited amount of data that they have. So it's only natural that they look towards tooling focused on data that can help them do that. So
there's no disagreeing on panels. So, I'm not allowed to disagree. But anyone else, or JD, want to jump in on that as well? Are you seeing the same thing, like a proliferation now of kind of tools that are addressing it?
I feel like I am, but it's a pretty recent thing. So, I would hard agree with this question a year ago, and now it feels like it's starting to change. And I think that a lot of it comes from the kind of academic roots of machine learning, because when machine learning was an academic process, it's still an academic process, but when it was a sort of exclusively an academic process, you actually were very disincentivized from focusing on the data, right? Like you would basically want to do a model on ImageNet, and the point was that you wanted to have a better performing model on the same data. And if you use different data, then like your research sort of wouldn't be as valid, because it'd be like, well, like you just had a better data set. This doesn't prove that you've done actually something more interesting with the model. So I think that machine learning sort of evolved a lot from that and is starting to shed that, because to be actually useful, a lot of the development is happening in the data. I also think that because of this, data-centric stuff just feels a little bit more blue collar than the model stuff. Like the really sort of cool stuff people feel like in machine learning is, coming up with this really cool new training method or some new architecture for the model that just feels like, oh, like this is a real like breakthrough or something like this. The fact that you wrangled a ton of data really, really well and it's perfectly labeled and everything, so it's a great training set, like it's hard to publish a paper on that. But practically speaking, that is proving to be the most important stuff right now.
Yeah, and I think at the end of the day, we still have a huge gap between data and decision. It's not easy to go just grab data, especially at the volumes that some of these companies are storing their data. There's still a ton of data engineering and infrastructure that has to be thrown at the problem. Even for training, but more specifically for production. So we ended up in a world where a lot of the production infrastructure is doing offline versus online, right? It's sad when I look deep inside of some of these companies that are doing amazing fraud detection, right? Those fraud vectors are pre-computed. So I feel like the discipline of building models tends to be very different. It's like building the front end versus building the back end. And there's still just a big gap between those that can wrangle the huge growing data sets and those that are building the models on it. So I think that gap needs to go away. And, we tend to think about data from a human perspective still. This is very much one of our mantras at FeatureBase. And we believe that the more we can automatically label data, we can label data on the fly, that we can compute on our raw data And we can, instead of putting it in human-centric formats, put it in machine-centric formats, right? From the get-go, it's going to close that gap so that we can compute on our raw data in real time. And it's just access that's standing between us, meaning the models, and the data on the back end, and not a ton of infrastructure and engineering that we have to face today.
Yeah, that's interesting. And it's also part of the thinking behind a lot of the synthetic data kind of companies, right? You can kind of label and generate the data on the fly, although there's still a huge chunk of sort of machine learning challenges kind of to solve there at some level too, right? And some of it's far ahead, some of it's not, right?
Yeah, exactly. And if you think about it, we almost always move data to the models. We're not moving models to the data. And that means we're copying and moving data, right? That means we have to have systems and pipelines and batch processes that are doing all of that. That just introduces complexity and keeps driving that divide between the data and the decision.
I think also the science has changed a bit, right? In that there's kind of Rich Sutton and his sort of the bitter lesson, right? That it's like, well, we're going to need all these, we just scale up the data and it works and the GPUs go burr, right? And whereas in the past, no, you can't do this. We need to have, latent understanding and human interaction built into it and all these models. And then there's kind of the classic joke of every time I, fire a linguist, the performance goes up 10x in my NLP model. And then I also think that the models in many ways are not changing anymore, right? It's if you look at, there was the joke at NeuroIPS, which they had this hilarious, kind of montage. And one of them was Vaswani et al. Still, relevant, and cutting edge, since 2017, right? Which was the attention is all you need paper, right? And it seems like transformers have basically eaten the world and started to say, we're going in this direction and just scale it up. And then you get the chinchilla paper, which essentially says you got to keep adding more data, right? And all these models are actually radically undertrained, right? So we seem to have moved to this point of grab as much data, make it as labeled, and perfectly labeled as possible and hurl it at the thing and it'll figure it out. So I think there's been a shift, and I think, you're right in disagreeing with it, that it's just sort of a new way of looking at it, right? And data-centric hasn't been old, but now there's kind of this sort of new proliferation that's coming along. Do you think, though, that I think you're probably going to agree with this one, but do you think that the fact that we're seeing sort of a surge in business on the labeling sides of the house and and a lot of machine learning on that front too, right? Semi-supervised learning and all these things kind of helping speed it up. And somebody mentioned, you mentioned Stable earlier, and they used Clip to do kind of downloading and the text pair is kind of automatically generated, right? Do you think it's because people are now starting to deal with these kind of bigger data sets and figure out what the heck they want to do with them? Or do you think there's sort of kind of another reason that people are kind of pushing along on that front now?
That's a good question. So I think it's the other way around. So people are getting access to so much data that they need new techniques and technology to be able to wrangle and handle these data. So they're coming up with feature store, which we'll talk about in a bit, or embedding store for computer vision, and all sorts of computations that has to do with embeddings. For example, searching data or similarity search or curation, things like that.
Yeah, so you're thinking it's not just you're thinking it's not just that people are now getting around to these, but it's actually that they're figuring out how to get access to these and getting access to a whole bunch more. That's essentially, so that's interesting. That's in contention. And HR, I cut you off. What were you thinking?
Yeah, I was just going to say, I think the world of labeling is fascinating to me. I'm obsessed with this idea of compute ready data, decision ready data. And to me, labeling is one of the very first steps in that. And so labeling is in its infancy. Everything around me needs to be labeled and everything's pretty domain specific. We tend to start with sort of some human machine partnership in creating these labeling systems. And as that becomes more and more automated, I think labeling will be part of our data modeling, right? As we create data, it will be labeled and stored in this compute-friendly format. And I think that solves a lot of the other problems that we talked about earlier. And I think, these innovations on the labeling side are a huge step in the right direction, right? You can make a decision on a label, but not a video frame. So I'm pretty bullish on where this is all going in terms of helping solve this data model divide.
Yeah, I think that labeling is one of the pieces of the sort of like broader ML picture that has sort of been fairly cracked from a product perspective. Like people sort of understand what that labeling product is supposed to do precisely enough that like there can be an entire market around these things. I think that hasn't happened through a lot of ML. I think that there's a lot of, and that's why you see a lot of other products where it's like kind of hard to pin down exactly what they do, right? And there's like overlap in different places. And, you know, like if you look sort of at the actual infrastructure and what they're doing, it's like, okay, like, yeah, this is how it's shuffling around bytes. This is how it's leveraging compute and stuff like that. Whereas labeling is one of the only things where like, if somebody tells me like, oh, this is a labeling product, I more or less know what I'm going to see in that UI when I open it up. You know, not exactly, but I know sort of the features to expect.
Interesting. And then, you know, kind of moving beyond the labeling, which is, you know, still one of the, I think gathering the data and all these things is one of the biggest bottlenecks, and labeling is not sort of far behind it in terms of like where people spend the most of their time. Mm-hmm. And even when we started looking at it at the IA perspective in the early days, I do think it was true that most of the time, the vast majority of the tools were on the experimentation to deployment to serving phase. And it was kind of like, well, the data is going to get in here somehow, right? And it was like, I don't think it works that way. Like, I think there's a lot of pulling this stuff in and from lots of places and navigating the politics of the organization and bringing it all together. So it is kind of exciting to see it sort of shift back in the other direction and go, well, this is actually, it does matter a great deal. And since we're speaking about that, like you got some preview, you pulled back from the preview, JD, which was good, but let's go to the data versioning and lineage section and let's talk about why is it sort of become a newfound necessity in AML, and then there's kind of a follow on to this, like, is it just something that people didn't see coming, right? Or is it something that like has fundamentally changed in the way we do sort of snapshotting and versioning now when it comes to data?
I think that a lot of people did see it coming. I think that, you know, it became a necessity. I'll sort of tell you the story of when I realized it was a necessity as a practitioner, which was I was trying to debug a fraud model at Airbnb, and something had just gone horribly wrong the night before. We were running on like a one night cadence on this stuff, no real time anything. And I just had no idea how the data had changed. And like, I was like poking through our HDFS. This was like 2014. And I was like, where did this model come from? What did this look like yesterday? I was like going to individual servers and trying to get logs. And I remember having this sort of aha moment of like, oh, like the issue is that I don't have the tools that I have for code. Like if this was Git, I would just basically do a bisect and I would be able to see exactly what change introduced this. And stuff like that. And I really, really wanted that for data. And so that was sort of the system. That was the biggest idea that we set out to build with Packaderm, was the ability to sort of version these data sets and track the lineage between them. And I think that, you know, this is important across all sorts of data science, even like really simple stuff. But with models, it becomes that much more important because the models themselves are opaque. And so you can't really interrogate the model. All you can do with it is take an inference. And so, you know, people record metadata about their models, which is great because that's kind of a summary. But really, when you want to be able to interrogate what went into a model, you want to be able to look at all the data that went into it. And because when you can do that, you can sort of learn anything up to and including completely reproducing the training process and reproducing the model. So that's, you know, a short spiel on versioning. I could go on for days about this stuff. But I'm interested in taking it over to these guys because I think that they may, I don't know, they may disagree on some of these things because I'm a sort of like versioning zealot.
So non-versioning zealots, maybe H.
Yeah, I don't know if there's non-versioning zealots, but they may not be zealots.
Yeah, I mean, I think I have perhaps a strong, maybe even controversial view on all of this. I mean, I think the labeling is certainly a step in the right direction, as we talked about earlier. But versioning and lineage to me are an aberration of all of the attempts we make to try to fix all of these problems. We end up having to transform, batch, ETL, clean data. A lot of that is manual processes. They get automated. And so there's 5 or 6 steps between raw data and feeding a model. And so keeping track of all of that is a complete nightmare. Recreating that is a complete nightmare. And that gauntlet of data is very hard and very important to recreate. And so I think at the end of the day, when we can compute on the raw data in real time, we solve all of these problems. I mean, just take, for example, it's like standard practice at Databricks to store your data in bronze tables, and then you stage and transform and move it into silver tables. And then you're going to feed it into your applications or your models in gold tables. That not only takes 20 minutes, but tracking all that back. And as you make changes to every piece of that, being able to track all of those versions is impossible. Imagine if we were just computing on a platinum table in real time. That was the raw data. And we were shifting our lineage and versioning to the code that our model is generating, using, versus the brittle pipelines and all of the manual steps that happen, right? Ideally, those transformations, those aggregations are happening in our model and in our code and not in a really complex infrastructure environment.
Is that realistic though? I mean, before we get to Hyun on this, because that is pretty radical. And the old IT guy in me is like, the hell are you talking about, right? You know what I mean? There's no way we ever get to a point where we have super clean data all the time. Obviously, if you're feeding it from a real-time platform or you're feeding it in regularly, and there's a lot of consistent process. But I mean, if we're talking about a gigantic data set, is that realistic? And how does it work?
Yeah, no question. That cleaning is not going to go away, but that cleaning should not have to create yet another copy and stage it in yet another database, right? That cleaning should be that cleaning should be code that's running on the fly during that cleaning, and you're versioning your code, and you can keep track of that, but you're not having to keep track of all of the copies of all of the data that you're making. In fact, the problem is so bad that 88% of all data in the world today is copies. Only 1 in 10 is actually original data. We copy and move our data in order to solve these problems. If we could just operate on that one original piece of data, I think the world is a very different world.
Okay, that's interesting. I see where you're going with it. Ken, what do you think about all that in terms of that workflow and the possibilities?
Yeah. Well, I just wanted to add another perspective to this discussion. Me coming from the computer vision world, I think there are few additional complexities to data versioning for unstructured data or for computer vision data. So one way to track versions for computer vision data is computing the features or the embedding vectors and then versioning these feature vectors instead of the raw data. And of course, that comes with a few caveats. For example, using deep learning for extracting feature vectors out of images or videos, that can be quite expensive, obviously. And then also, if you're dealing with feature vectors, you are basically risking losing important details of important details that are contained in the raw data, but were lost during the feature computation. And then also, there's the thing where if you ever update the algorithm that you use for computing these feature vectors, you're basically retraining your deep learning models for your feature computation. Or if you use a new model that changes the length of the feature vector, for example, you're basically working on an entirely new different feature space from that point on. So, that adds more complexity to the problem.
It feels like old IT problems, just they never die. They just go to hell and regroup, right? I mean,
there's 3 IT problems since the beginning of time, and we just keep solving them in different ways.
I distinctly remember a SQL server changing silently a sort from A to Z to Z to A, and not documenting it, and us just sort of going, what? Why is this query failing now or giving wrong information? And it's that same thing even you see now in genetics or something like that, where they change the impute algorithm for missing genetics code, and now it's just totally different because, of course, it imputes it in a different way, right? So there's these kinds of things that come to pass. But you actually raised another interesting thing, Hyun, and I'm going to kick it right back to you and then go to everyone else. Unstructured data, I've said in the past, I think is the unsung hero of machine learning. I think when you really look at a lot of the cool stuff that's been done out there. When you think of AlphaFold, you think of Dolly, Stable Diffusion, you think of you think of all these kind of self-driving car, anything that's like sexy and cool at some level. It was unstructured data. Do you think that we ever get to, and HO, I bet you're going to have a sort of sense of this as well. Do you think we actually get to a unified system for dealing with this? Because there's been a lot of marketing around, quite frankly, right? Where we sort of are able to deal with structured and unstructured data in a seamless way. But this again feels like one of those hellish IT problems that's existed for decades. I'm not sure if it gets solved, but what does everyone think here? Is there going to be a unified system, or is it basically an impossible engineering feat?
That's a hard question. I hope there's a unified system in the next 10 years, but it's probably more difficult to deal with than we expect right now. There are, as you see, a ton of startups and these companies tackling that problem, building a unified framework or infrastructure for data wrangling and everything for unstructured data. But I don't think it's something that a single company can do ever. So that's why we have the AI Infrastructure Alliance.
Well said, sir. Thank you for the plug. HO, what are you thinking on this front?
Yeah, I mean, I think there'll be less of a system and more of a stack that can handle this in a unified way. Right now, it tends to be overly complex. I mean, computer science 101 sort of teaches you that data, information, knowledge, wisdom pyramid, right? So I kind of fundamentally believe that all data starts unstructured. It's just today, our structured and semi-structured data got labeled by the user who did the wire from their Wells Fargo account online, but it was unstructured before they entered that wire into their platform, right? So at some point, all data starts unstructured, and I think we're just at various stages of how we perceive all of that. I think at the end of the day, it will blend and morph into one, and we won't see those distinctions.
JD, I know you're going to have some strong opinions on this. I mean, we talked a lot about this at Packaderm at various points. Right?
Yeah.
And that, so.
So to answer sort of the first question of is this a sort of fundamental problem that there isn't an answer to? I think the answer to that is definitely no. I think that there is no sort of fundamental computer science reason. It's entirely sort of a path dependence problem that comes from this very, very unfortunate decision that was made probably before any of us were alive to have databases and file systems be these kind of completely different ways of looking at data, even though at an infrastructure level, they're almost exactly the same thing. They're both a B-tree model backed on this. But unfortunately, they were just they were thought of in these different ways, and they all developed these different APIs, which have all of these quirks to them. And so merging these two is kind of the ultimate merge conflict in all of coding, because there is so much code and there is so much understanding built up around each of these systems that getting them to talk to each other is really, really difficult. I think that a kind of something that's really interesting to me lately is that object storage has kind of become a legitimate third leg to this table of these, and that object storage it's certainly not structured. It's not even really a file system. It's simpler than both. And as such, it can kind of operate in both worlds, right? And that you can have, most people who run Spark are running it on top of object storage, and they have Parquet files or some other similar format stored in object storage. And so then it becomes kind of structured, and you can also sort of treat it like a file system, even though it has its idiosyncrasies there. So I guess I would say I'm not super optimistic. I think that something really big needs to change in terms of how, because like Juan said, I don't think that one company can build this. I think that you would need an organization like Aya, but it would need to be more powerful than I don't think even the Linux Foundation, even maybe if the Linux Foundation and Apple and Microsoft all got together and were this is the problem we're solving, this is what's holding us back, then you could do something about it. But that's never going to happen.
Yeah, well, the eye has always been punching above its weight for a while, but yeah, I agree that we'd have to get to a bigger.
I don't think we can punch this far above our weight. Like,
there's a level of like where you put on the headband and it doesn't actually make you know kung fu.
Like you drink secret stuff and it turns out it's actually just water. I think you would almost need, and I wish we sort of had more of this. Like, I think you would almost need like a governmentally backed standards body to do something like this. I think it's something, a smaller version of that task that I've really, really wished that we would have a standards body like that do is I wish that we had an equivalent of POSIX for object stores. Because I don't know about you guys, but just like getting a product that can work on the 3 major object stores on the 3 major clouds is already a heck of a challenge. And those are just object stores, like they're not fundamentally different in their APIs the way that like a SQL API is from a file system API.
So then shifting gears a little bit on this, like HO, do feature bases, feature stores, like, potato, tomato, like do those things play a sort of a role in dealing with some of the problem? In other words, like, is it an abstraction layer that we just put over the top of things and then that kind of gets us somewhere? Is that a path to victory?
I mean, I agree that it's not going to be easy, but that's the utopia that we seek, for sure. I mean, I do think, especially with the proliferation of these cloud data warehouses, they've become the new storage layer. They've solved a huge organizational problem, whether we like it or not. And companies are centralizing their data rather than have 500, 1,000 databases in a Fortune 500. They're now all in Snowflake or they're now all in Delta Lake. But that still presents a computation problem, a data readiness problem, a labeling problem. And I think being able to compute on that storage layer in real time is going to be really critical. So I think that new layer of real time computation is developing. You can already see some of it happening with some of the database startups like ReadySet, that allow you to move a replica of your database anywhere. I think sort of this real time computable representation of data will develop above that storage layer and between our apps and our models. And I think, certainly that's where we're spending our time over the next few years.
And I mean, one of the things that was sort of interesting when sort of feature stores kind of broke onto the scene and everybody was adding it to their chart or whatever, right? It was almost all kind of a structured data thing, right? Because there was kind of this idea that you could examine the feature and go, yes, I have calculated age correctly, but like when you're like, this is a string of numbers, like I don't know whether that's like, a part of a nose or not. Like, is there a space for this in the unstructured world?
Exactly. And I mean, I think that's sort of the permeating point here on the labeling side is that a feature is just a decision ready data point. You can make a yes, no decision on a feature. You can't make a yes, no decision on a nose. So label that and convert it into a classification, categorize it and store that. You can make a decision on it. And so our pitch to the world, and while we might not be able to do it on every type of data today, is automatically do that conversion when the data is created and store it in a decision ready format. At the start, we call it a feature first future, as opposed to a feature last. Today, it's pretty sad when you think about feature vectors in production. They're all pre-processed. They're all calculated ahead of time. They're not calculated on the fly. And we talk about fast, right? Do we want feature stores to be fast? Well, define fast. Is fast cached? Because most feature vectors are cached. They're stuck in Redis or some sort of other cache. Yes, they're fast, but they're not fast in terms of real time. They're not computed on the fly on the latest data. And to me, that's fast, right? So in any event, I do think that this real time, fresh layer of computation is going to emerge to solve this problem for us.
Yeah, what do you think of it? Do you think that there's room in the future for more things sort of being computed on the fly or labeled on the fly, or will you think we're sort of many years ahead of it and we're still kind of grinding it out in the old IT world of like manual labeling and some semi-supervised learning?
I think there are some exciting progress in that way. And then to add to Joe's point, I I think, feature store or embedding store for computer vision, it's not just for computation speed. It's also basically infrastructure that enables you to basically search through your unstructured data, right? So, a lot of the cases when the machine learning team is, pretty mature, let's say the model performance is pretty saturated. Like 99.99% of any new training data will have zero value, right? And the challenge comes from finding the 0.01% of useful, valuable data. And I think a feature store or embedding store can be the infrastructure that enables you to do that. So, like, for example, let's say you're building a self-driving car, like within a batch of like newly collected footage of a car driving down a highway. You're probably only interested in the rare events, like such as the car driving under a bridge, and then there's like a person in the shadow of that bridge that you can't really see. Like it's a huge time save. If you can find these frames using feature vectors or embeddings before you annotate the entire video footage, and then use the like annotation information to do the search, right?
I mean, it seems like many of these. Actually, I read something on self-driving cars where it's like we're 99% of the way there, but that 1% is like another 99%, and that half of it is really them just looking for additional edge cases, right? That one time where it is a shadow or someone randomly steps into the road when they look like they weren't going to, or it's a divider that has the same color as this. Like half of it is just them really looking for those edge cases and hoping to collect enough data that it becomes safe. That's interesting.
Yeah. So I think like when you're in the initial phase of your machine learning project, like the challenge comes from like labeling and like QAing large scale training data. But once you're after a certain point, the challenge comes from like searching for these rare events and edge cases.
Interesting. So, JD, I think we kind of hammered on that one. So let me go on to one last one here, which is not on the list, right? I'm going to throw you guys all a curveball, right? So, you guys, JD, we're going to start with you on this one. There's somebody, a VC or a bunch of customers drive up, to Packaderm with a truck of money. It's just $500 million. And say essentially you can build whatever you want, over the next 5 years. But you've got to pick the thing that you think is going to have the most impact. And I'm gonna toss this one to everybody, right? What do you start working on at that point? What do you think ends up having the most impact if you basically money is no object?
Ooh, that's a good question. I mean, I think that I would, obviously, like the boring answer is that I sort of put more resources into what we're working on now because, like, I have, I haven't been given $500 million by investors, but I've been given some millions of dollars by investors, and like it felt like sort of the same question at the time. But I think that I would sort of try to like really unify an end-to-end experience. And I think that in a lot of cases, like, and I think that it's hard to do a lot of that in-house. And so, not to imply anything with this answer, but if I had that much money, I would probably consider acquiring companies like the ones that are represented on this call, and like, because it's just like, hey man, like they just gave me $500 million. Like, let's all work together. Like we, like basically like let's have Aya be a company and see if we can like compete with the cloud providers on that type of stuff. And that's actually kind of one of the interesting issues, because I think that there are, and I'm sure that you guys have experienced this too, like, there are a lot of sort of practical business challenges that you have to solve that I think are the technical challenges that are the most interesting to people like us. And so just the fact that you have to sort of like work on all of the different clouds and work with the clouds, and a lot of times, they have sort of internal products on the clouds that aren't quite as good, but they're native to the cloud. So you sort of have to compete with the home court advantage there and stuff like that. The idea of an AI ML specific cloud provider seems kind of interesting to me. It it seems like it takes a lot of resources, but that's kind of the point of the question. I don't know if 500 million is even.
It might not be enough. Yeah, let's pretend it.
Yeah, but let's be real. If somebody comes up to you with a truckload of $500 million, then chances are you could ask for more, and they wouldn't within the realm of this question. So yeah, I think that's what I would focus on. And like a lot of the things that we've talked about in this call are sort of like what goes into that. So like you imagine like the sort of like the real-time systems that we're talking about and the tracking systems and everything like that. Imagine if you could have that for like the entire cloud end to end, because like there's still having the data be real time and stuff like that is amazing and improves your velocity a lot. But like you're still not going to have your nodes spin up in real time and stuff like that. And maybe you don't need to, that's just sort of one example, but there's all sorts of latency that the cloud sort of impose on you that of course you can get around, like you can pre-warm stuff and things like that, but you have to get around them rather than it just being the cloud is built for stuff to just be like flowing really quickly and having the lineage be tracked and having everything be versioned.
Hey, Joe, you just got $10 billion. What,
I love it.
What are you going to do with it? What are you building?
I think my VCs planted this question to test me, so I have to answer this question very carefully. So for the next 12 months, I'm going to stay very focused on my roadmap. I think real time in general, though, is very, very new. I think the adoption and the importance of real time is grossly underestimated. We see it every day on the field. It's very misunderstood. So I think we've got, a couple of years of letting this wave hit in terms of real time. We're very focused on the core capabilities of building a fully functional OLAP database on bitmaps, and building a database is not for the faint of heart. We're getting pretty close. And so I would spend that 500 million on sort of the next longer term roadmap, sort of our 12, 24 month, 36 month roadmap. And, we loosely internally call it compute cloud, based on some user defined functions, embedded model execution capabilities that we're building. If it's true that you can compute on raw data in real time, I would love to be able to take, labeling models and algorithms and embed those directly in the database. I see a world where we're moving models to the data and not data to the models. If we think of our best of breed SaaS companies today, Palo Alto Networks, Zscaler, guess what? 100% of their customers move all of that data to them. We pipe and ship all of the data so that they can run their models on your data. Imagine a world where they're shipping their models to your data and you're in complete control, and you're securing and perhaps even networking the output of those models and not the input, right? I think it absolutely changes the dynamic of the world. And so this is sort of our big idea and where I would spend all of that money. Now, I got to put one foot in front of the other, but I do think that true real time unlocks the ability to move models to the data. And that's what I would work on.
And I just got a text message from your investors, and they said, good answer. Take us home with this, man. We drove up $10 billion bucks, just do whatever you want. Like, what are you building with it? What do you see as the most impact in the next 5 years?
Yeah, I'm pretty much with JD and H on this one. If I were to give them the money, I'd want to build an end-to-end platform that spans the entire gamut. What we're building right now is computer vision, data labeling, data QA, data curation platform, and what we're building now has a lot of potentials when it's integrated or used together or expanded, to the entire value chain, right? Like earlier in the ML dev cycle, like we might put more resources into like data collection side of things. Could be synthetic data like diffusion models, and then also like later in the ML cycle, model side of things, model training, model analytics, deployment. Like you really have to close a loop from like model deployment back to data collection in order to build like an end-to-end platform. So that's what I would want to build, and that will definitely involve acquiring other companies. So that'd be fun.
And integrating them well. I mean, that would be. The thing is, it wouldn't just be. Certainly, other mega companies have tried this in the past, and it hasn't always gone smoothly. I was a huge fan of VMware for much of my life, and their initial platform was incredible. And their enterprise platform was incredible and sort of took over the market. And they probably acquired 20 or 30 other companies maybe one or two of those that got integrated quite well, and most of the rest didn't, which is interesting. So it's a challenge either to build this thing in and of itself. And I'm not sure, I don't know that anyone pulls it off in the next 5 years, because when I look at around the horn here, right, and I look at all the companies when we were researching the report, and I realize how many things you have to be good at. It strikes me as like those kind of job ads when there's like a downturn and they're like, we're looking for someone who's a CCIE plus like certified with security, plus who's been coding for 50 years, plus who can do, DevOps, can stand up Linux in an HPC cluster. And you're like, yeah, that person doesn't exist. And I feel like at this point that we're still sort of figuring out so many different aspects of this thing. So, that brings us back to the conclusion of the report, which is best of breed. And it's one of the reasons we brought the IA together, right? To get a lot of folks working together, because that kind of pure end-to-end system is a siren song still. Maybe somebody pulls it off. Maybe there's a kid with a whiteboard somewhere working it out who's a super genius, but I haven't met that person yet. So we'll see. But wonderful. Well, this was a lot of fun. I appreciate everybody's time. I think hopefully everyone enjoyed it out at the conference, and you're getting having a ton of fun out there. And I know I had fun. Thank you to each of you three for coming on and for some great answers. Appreciate it.
Yeah, thanks for setting this up, Dan. This is great.
Thank you, Daniel.